Okay, so yesterday I talked about resultant forces. Resultant forces are basically the sum of all forces acting on the body. This next part. Okay, so we know that a resultant force causes an acceleration. So Newton's second law actually says that there's a relationship between the resultant force and the acceleration. There's an equation, F equals ma. So F is actually the resultant force. So when they say F, the force needed to accelerate a particle is equal to the mass of the product, mass of the particle times by the acceleration produced. So when they say F is the resultant force, it's the overall force. F is the resultant force. So you'll be using that equation a lot. Resultant force equals mass times acceleration. So that equation is called the equation of motion of a particle. So that equation describes the motion of a particle. So it's called the equation of motion. Equation of motion. Okay, so for the simplest case, I guess, if you've got like 1, if F equals 1, M equals 1, and A equals 1. So what this is saying is that a force of 1 Newton will cause a mass of 1 kilogram to accelerate at a rate of 1 meter per second squared. So that's like the simplest possible equation you could have. Okay, so if you do physics, F equals ma should be very familiar to you. Okay, so you can apply that equation to gravitational force. Okay, so gravity is the force between any object and the Earth. Okay, so remember, when you drop an object, it's accelerating towards the Earth at 9.8 meters per second. Okay, so A equals 9.8. So they use a special letter for it. A body falling freely experiences an acceleration of 9.8. So they use the letter G. Okay, so the acceleration due to gravity, they use the letter G. Okay, so G is equal to 9.8. If you do physics, then it's 9.81. Okay, so that's the acceleration due to gravity. Okay, so that means when you multiply an object's mass by G, you get the weight. So when we talk about the weight of an object, it's different to the mass. Okay, to work out the weight of an object, you calculate the mass multiplied by G. That's how you do it. So, for example, suppose a person has mass, say, let's say 78 kilograms. That means their weight is going to be equal to 78 multiplied by G. So you would do 78 times by 9.8. And that would give you 764. So according to my calculator, 764.4 newtons. Okay. I suppose strictly speaking, again, because we're using G to 2 significant figures, then strictly speaking, if you follow the book method, you would have to give your answer to 2 sig figs, strictly speaking. Okay, so to work out something's weight, you multiply the mass times by the value of G, which is 9.8. Okay, so don't get mixed up with grams. Okay, any questions you want to ask me so far? I haven't done anything yet, really. Okay, so examples I've got. Okay, so in the book, first example, just using the equation, acceleration when a particle, okay, so you've got the mass, m, you find the acceleration, and you're told the resultant force is 6. So you just plug it into the equation, F equals ma. So that'll give you 6 equals 1.5 times a. Then you just do 6 divided by 1.5. That tells you a is equal to 4 meters per second squared. Okay. In these examples, you're given a body and you want to find x and y. Okay. So you treat the horizontal and the vertical as separate components. Okay. So in the book, they use this notation. Don't like it, but that's what they use in the book. That means you need to consider the horizontal motion of the object. So you need to consider the horizontal forces. Okay. So the R stands for resolving. Okay. So the R stands for, it's called resolving. Resolving horizontal forces. It's just the symbol they use in the book. Resolving horizontal forces. So you want to figure out an equation of motion for the horizontal forces. Okay. So on this body, the motion is towards the right. So that's an A value, acceleration. Okay. The horizontal forces are X and 4. So 4 newtons is like friction, if you want, or drag. Because the motion is towards the right, you would say the resultant force. So you'd say the resultant force is X minus 4. So that's when you say it's important to get the direction right. Okay, so you would say resultant force is equal to X minus 4, not 4 minus X, because it's moving to the right. That's the overall force in the horizontal direction. Okay, then you can use Newton's second law. So Newton's second law says that the resultant force, so this is using F equals ma, but in the horizontal direction. Okay, check my recording. Yeah. Okay, so F equals ma, X minus 4 equals the horizontal acceleration is 2, and the mass is also 2. Okay, so that's 2 times 2. So you get X equals 4 plus 4. So X is equal to 8 newtons. Okay, so that's how you use the equation of motion to solve the value of X. Okay, and then you can do the same thing for the vertical. The book, they use this symbol, upward arrow. So it just means you need to think about the equation of motion for the vertical forces. Okay, so on the vertical forces, you've got y upwards and you've got 2g downwards. Okay, so 2g means 2 times 9.8. Okay, so if you take the upwards direction as positive, the resultant force will be y minus 2g. Yeah. Okay, so the resultant force, the overall upward force, will be y minus 2g. Mass is equal to 2. Okay, and there is no vertical acceleration. All the acceleration is towards the right, so it's not actually accelerating upwards. So a is equal to 0 in this case. So the vertical acceleration is 0. All the acceleration for this body is towards the right. So that is your equation. So you can solve that to work out the value of y. So y is equal to 2 times g. But remember, g is 9.8. So that will give you 9.8 times 2 is 19.6. newtons. Okay, any questions on that one? Okay, second one. Okay, second one, same kind of idea, a bit more complicated, I think. Oh, wow. Okay, so I'm going to resolve, okay, so the motion is towards the left. So that's like an A value. So in the book, they use this notation again. I'm going to resolve forces horizontally. So I need to think about the horizontal forces. Okay, so the motion is towards the left. Okay, so this time I've got 80 to the left, and this is like, you can think of it as friction. Okay, so the resultant force will be not x minus 80, but 80 minus x, because it's accelerating. The motion is towards the left. So you take the pulling force, if you want, 80 take away x. So Newton's second law says the resultant force, 80 take away x, is equal to the mass times by the acceleration. That is the equation of motion. Resultant force is 80 take away x, mass is 4, acceleration is 2. So if you solve that equation, you get 80 minus 8, which is 72. So if you solve that, you get x equal to 72 newtons. Okay. And then the other unknown, okay, so to find y, you've got to think about the vertical forces. So you're going to do F equals ma on the vertical forces. So on the vertical forces, you seem to have three things going on. Okay, so you've got a force going downwards, 4g newtons. You've got another force, 20 newtons, which is also going downwards. So that will go together with the 4g, and then you have an upward force. Okay, so to work out the resultant force, again, if you take the upwards direction as being positive, the resultant force will be y take away the sum of the two downward forces, 20 plus 4g. That is the resultant force in the vertical direction. And that, again, that is equal to mass times acceleration. Mass is 4. So again, all the acceleration is to the left. There is no vertical acceleration. It doesn't say that. So it's not accelerating vertically, so it's just 0. So that's y equals 20 plus 4 times 9.8. That's the value of g. Okay, so again, that will give you 59.2. That's what they got in the book. Again, that is in newtons. Okay, any questions on that? The last example they've got, example 7. Okay, so it's always important to draw a diagram to help you think about these things. Okay, you've got a body of mass, okay, 5 kilos, pulled along a rough horizontal table. Okay, so start by drawing it out. So you've got a table. You have a body of mass 5 kilos. Okay, so that's my 5 kilo mass. Okay, so 5 kilos. Okay, so automatically it's in contact with the table, so there must be a weight. So the body exerts a force on the table, exerts the weight. So the weight is going to be 5 times g. So 5G newtons is the weight of the block. So again, automatically, the block is in contact with the table, so there must be a reaction force. So I mentioned that yesterday, because the block doesn't fall through the table, so the table exerts a force on the block, which is in the opposite direction. So that is your, okay, they use the letter R again. Okay, so that is the normal reaction. Okay, so the word normal basically means like perpendicular. Reaction is like a contact force. Other information, it's been pulled by a horizontal force of 20 newtons magnitude. So it's been dragged along the table, 20 newtons. Okay, against a constant friction force. So the friction will come from the rough table. That's like opposing the motion. We've got 4 newtons opposing the motion. Okay, so obviously it's been dragged to the right. So you can think of it as the A value. Acceleration is towards the right then. The A is unknown. That's what you need to find. So those are all the forces. And it's been dragged towards the right. So the first part of the question says find acceleration. So the acceleration is towards the right. So you've got to think about the horizontal motion of the body. So for part A, you think about the horizontal forces. So there are only 2 horizontal forces, 20 and the 4. So you've got, this is the horizontal, that's the horizontal motion to the right. So the resultant force is 20 take away 4. Okay. So remember, Newton's second law says resultant force is mass times acceleration. So resultant force is 20 take away 4. The mass is 5, and the acceleration is unknown, 5a. So you can solve that equation to do 16 divided by 5 to give you 3.2. That's the acceleration towards the right. Okay. Part B, you want to find the distance. So that sounds like it's going to be a Suvat situation. You want to find S, and T is 4. So in part B, you want to find the distance traveled. So S, displacement from starting point. T is 4 after 4 seconds. The body is initially at rest. That's important. So the initial velocity is 0. U equals 0. Okay, so we need a Suvat equation involving S, T, U, and A, because we know what A is. A equals 3.2. Okay, so it has to be S equals UT1. Okay, so S equals then, because U is 0, you just get 0. Acceleration we proved to be 3.2. And T, we worked out, is given to you as 4. So it's 4 squared. So if you work it out, 25.6 meters. Okay, so that's straight from the Suvat equation. Last part, part C, the magnitude of the resultant, the magnitude of the normal reaction. So you want to find out what R is. Okay, so you want to find out what this is. Okay, so you need to do F equals ma again, but you do it on the vertical. So for part C, you think about the vertical forces. So there's two vertical forces, the normal reaction and the weight. Okay, so you can take upwards to be positive. So the resultant force will be R minus 5G. And again, that we're using Newton's second law, F equals ma, resultant force. So the resultant vertical force is R minus 5G. That is equal to mass times acceleration. But remember, the body is being dragged along the table. So all the motion is towards the right. There's no vertical motion at all. So acceleration is just 0. So that means the normal reaction is equal to 5G. And G is 9.8. If you do that calculation, you get 49. So that is the normal reaction. Any questions?